Okay, this is the review video for the mathematics of chemistry test. Okay, so the first thing we need to talk about are mole conversions. Now, the main mole conversions that you have to do are from grams to moles and from number of things to moles. Okay, I usually teach this like the airport we talked about. Additionally, you can use the piece in your notebook. Obviously, you can't use it for this test, but what you really need to remember is the acronym DIMO. That means divide in and multiply out. Okay, so here's your moles. That's kind of like the airport. Here's grams and here's number of things. Okay, very rarely are you going to ask about number of things because really for the most part nobody cares. Okay, nobody cares about how many atoms there are because it's such a gigantic number you can't really do much with it. So more often than not you're going to be going from grams into moles or moles out to grams. Okay, so if I'm going from grams into moles, if I'm going in, I'm going to divide, and I divide by the molar mass. So whenever you have grams, you really need to use the molar mass. How do you get the molar mass? You add up all of the pieces of the formula. So for example, if my substance is CO2, the molar mass of it is the mass from your periodic table of carbon plus 2 times the mass of oxygen. And the total here is 44. That means 1 mole weighs 44 grams. If I have 66 grams and I want to go in and figure out how many moles that is, I'm going to divide in and divide by the molar mass, which is 44. I end up with 1.5 moles. And that answer should make sense. It makes sense because if 1 mole weighs 44 and I have 66, well, 66 is more than 44. Therefore, I should have more than 1 mole, which in this case I do. Now, if I'm going from moles out to grams, I'm going to multiply because that is, here, that's multiply out. So that's this other piece. By multiplying, I'm going to multiply by the molar mass. So let's say I have 0.5 moles of CO2, and I want to know how many grams that is. Well, I'm going to take the same molar mass that I calculated before, and I'm going to multiply 0.5 by 44, and I get 22. That should also make sense. If 1 mole weighs 44, then half a mole is going to weigh less than 44 or 22. The only time you're going to use the number 6.02 times 10 to the 23rd is when you're asked about how many atoms or how many molecules are in something, okay? It's the same as going from number of dozens to how many. So if I said I have 2 dozen eggs and I wanted to know how many eggs I had, I would multiply 2 by 12. The same thing applies to moles, except you have a much larger number. So if you're going out, if I say you've got 5 moles and I want to know how many molecules that is, you're going to take 5 and you're going to multiply it by 6.02 times 10 to the 23rd. If you figure out that you have 1.2 times 10 to the 24th atoms of neon and you want to know how many moles that is, if I'm going into the airport, I'm going into moles, I divide, and I divide by 6.02 times 10 to the 23rd. Make sure when you put that in your calculator, you're using your E button or you are putting it in parentheses. The last type of mole conversion question that you might be asked about is how many moles of atoms are in a given formula. So for example, if I'm looking at something like S2O3. Only time I've ever seen it on the Regents is if you have 1 mole of this. But they'll say if you've got 1 mole of S2O3, how many moles, let's put a question mark, moles of oxygen are there? The idea here is that all you have to do is pull the subscript of oxygen. If I have 1 S2O3, which is 1 molecule of it, I have 3 oxygens. So for every 1 molecule, I have 3 times the number of oxygens. So even if I have a dozen of them, I'd have 3 dozen oxygens. If I have a mole of them, I have 3 moles of oxygen. All right, so when you get a question like this that asks you about moles of atoms in a mole, so it's kind of like a mole-to-mole type question, all you have to do is pull the subscript. Additionally, what you might see is rather than moles of O, okay? Or moles of atoms, they might ask you about, instead of moles of O, they might ask you about moles of atoms altogether. Well, S2O3 has 5 atoms, 2 sulfurs, and 3 oxygens. So 1 mole of S2O3 has 3 plus 2, or 5 moles of atoms, okay? Those are the types of mole conversion questions you're going to see. The only thing you might have to know about liters, which I don't even think is on this test, is that the same temperature, same pressure, same volume, same number of particles. An application of mole conversions is your empirical or molecular formula. Now, if I'm asking you about an empirical formula, odds are I'm probably either going to do it in 2 ways. I'm either going to give you the molecular formula, and let's do one like C6H6O4, okay? So here's a molecular formula. How do I know it's molecular? Because I know that that's what the molecule looks like, and I also know I can reduce it. All of these are divisible by 2. So if I divide them all by 2, I get C3H3O2. That is my empirical formula. Empirical formula is in the most reduced form. So all the subscripts, the ratio of all the subscripts is in the lowest terms possible. That's very likely what you're going to have to do as far as calculating an empirical formula. I'll give you the molecular formula, and you just have to reduce it down. Additionally, you might be given percentages. So for example, for a question like 50% sulfur and 50% oxygen, what's the empirical formula? This one is the one that gives you, that's that 4-step process that we have in our notebooks that looks like a pyramid. Okay? The first step is percent to mass. And when I say percent to mass, I literally mean change the percent signs to gram signs. Okay? So I have 50 grams of sulfur and 50 grams of oxygen. Now, I change the percent to grams, percent to mass, and then mass to mole. Mass to mole, I'm going to divide them each by their molar masses. So sulfur, according to my periodic table, weighs 32, and oxygen weighs 16. So the number of moles of sulfur I have 3.125 moles of oxygen, and I have 50 divided by 32, 1.56 moles of oxygen, okay? Now, I can't have decimals in my subscripts when I write the formula, so the next thing I have to do is I did percent to mass, mass to mole, divide by small. The smaller one is the sulfur one. This should be an S, excuse me. The smaller one's the sulfur one, so I'm going to divide them both by 1.56. And I get a ratio of S1O2. So my empirical formula is SO2. If after this step you don't get a 2, but you get like a 2.5, you need to multiply both of the subscripts by something to get you the smallest whole number ratio. So in this case, I'd probably multiply by 2, and I would get S2O5. However, that's not the case here, okay? And in this problem, our answer would just be SO2. Now, the next question might give you the empirical formula or ask you to find it, and then wants you to find the corresponding molecular formula, okay? Now, in this case, what you have to remember to do is find the molar mass of your empirical formula. So the question might read, the question might read, your molecular mass is, there we go. The question might read, your molecular mass is 192. If that's the case, I'm sorry, my pencil's not really working anymore. If that's the case, what is your molecular formula? The mass of your molecular formula is 192. What does your empirical formula, how many times does your empirical formula go into your molecular formula? You have to find out what your empirical formula weighs. Well, sulfur weighs 32, and oxygen, there's 2 of them, and each one weighs 16. So the total there is 64. So I'm going to take this, and I'm going to divide this by 64, and I should get a factor of 3. That means that my molecular formula is a factor of 3 times my empirical formula. So I'm going to take my empirical formula, SO2, and I'm going to multiply it by 3. And I get S3O6. I should be able to reduce that down to back to my empirical formula, but I'm going to leave my molecular formula like this. So if you have an empirical and you need to find the molecular, take your empirical, find the molar mass, divide the mass you're given by the bigger number by the smaller number, and find the factor. Percent composition is very easy. It's just the part over the whole times 100, okay? So in this case, let's do something like, let's do SO2 because we were just using that. If I want to know the percent by mass of sulfur in SO2, I'm going to take the molar mass of just sulfur, which is 32, which I can get from my periodic table, and I'm going to divide it by the mass of the whole thing. Odds are the question will give you the molar mass, and they'll call it the gram formula mass, but if they don't, you can always look it up. This one would be 32 plus 2 times 16, which is 64, times 100. Make sure if you have to show a correct numerical setup, you include that times 100. It's important. Equals 50%. So this stuff is 50% sulfur by mass. Hydrates, oftentimes they'll ask you what the percent by mass of a hydrated crystal is. They usually are asking about water. A hydrated crystal is like with the lab we did with CuSO4 and then the dot. That dot does not mean multiplication in chemistry. It means included in the structure, 5H2O. So in this case, if I wanted to know the percent by mass of water in this hydrate, I'm going to take the mass of 5 waters, which is 5 times 18, and I'm going to divide it by the total molar mass, which is 160, because that's the molar mass of the copper sulfate, plus, because that dot does not mean multiply, 90, which is the 5 times 18. Not forgetting my times 100, and I should get 36%. So this formula is 36% water. Remember, a hydrated crystal has water as part of the crystal structure, and when you remove the water, it crumbles. The last thing that you need to know for this test is stoichiometry. Stoichiometry is very, very simple. They are simple proportions. Here is an example. 4 aluminum plus 3 oxygens yields 2 aluminum oxides. First thing you need to check is make sure your equation is balanced. Sometimes I'll give it to you balanced and sometimes I won't. For the most part, I think they'll be balanced, and if there's coefficients, odds are it is balanced, but it never hurts to check. The question will ask you about two things specifically. If they tell you you've got an excess of one, you can ignore that one and focus on the ones that it gives you numbers for. So in the case of this problem, if I said, all right, I have 10 moles of aluminum, how many moles of aluminum oxide do I produce? Okay, I'm going to start by going to my equation and pulling the two things I'm asked about, which are aluminum and aluminum oxide. Yes, oxygen is part of this equation too, but I'm assuming I have enough of it. When you get to AP Chem someday, that's when we have a little bit more information and we can't make that assumption. But as far as we are concerned, you can assume that you have enough of any other reactant. Then I take the coefficients, the mole ratio. Mole ratio comes from those coefficients in front. It doesn't matter which one's on top. All that matters is that if it's on top on the left, it stays on top on the right. So this part comes directly from my equation. The mole ratio of aluminum to aluminum oxide is 4:2. Then I pull it from my question. My question says I have 10 moles of aluminum. So I'm going to take the 10 and I'm going to put it on top because the aluminum is on top on both sides. Then I'm going to say I'm looking for the number of moles of aluminum oxide. Now I label them. You really don't have to, but I label them so I can make sure that if aluminum oxide is on the bottom, it's on the bottom on both sides. Then to solve this, I'm going to cross multiply. And I get that 20 equals 4x. And I divide both sides by 4. And I get that x equals 5. So that's 5 moles of aluminum oxide. Does that make sense? Yes, it does, because it's a 4-to-2 ratio. So if I have 4 moles of aluminum, I'm going to produce 2 moles of aluminum oxide. If I have 10 moles of aluminum, I'm going to produce half the number of moles of aluminum oxide, which would be 5. And that's the answer that I got. Doesn't matter which 2 things you are asked about, set up a proportion, and you should be able to get to the answer very easily. The key here is making sure that these two, if it's on the top on one side, it's on the top on the other side. That's pretty much it. Good luck.